All right, so I'm going to walk you through today's notes. So we're going to go over 4 problems. It's going to be the addition property of equality, subtraction property of equality, multiplication property of equality, and the division property of equality. So what you're going to do first is you're going to look at what equation is being modeled. So you're going to click on where it says here, and it's going to take you to the website that's going to show you the equation. So here's our equation here, and make sure you take a screenshot of this, and then make sure you paste it into the Google Doc. So you can see that I put my screenshot right here, and I'm just going to type into this box the equation that I'm modeling here. And there you go. So the equation being modeled is x plus 2 equal to 2. So remember, your equal sign is basically what splits up these two sides. X plus 2 equals 2. Remember, to solve an equation means we need to isolate the variable x. We need to get this by itself. So you look at what else is on the same side. We have 2 1s, which means I have to get rid of those 2 1s. And the only way to do that is by creating 0 pairs. Now you can see that I added 2 negative 1s, so I can create 2 0 pairs, and that'll get rid of my 2 1s. But you'll notice now that the balance is not even anymore. So again, before that, if I delete it, you can see it's balanced. But the moment you add 2 negative 1s on the left side, it's unbalanced. So when you're solving an equation, you want to make sure the balance stays the same. So I'm just going to highlight these 2 negatives. I'm going to make a copy of it and put it on the other side, and you'll see we have balance again. This is called the subtraction property of equality because you're subtracting 2 to both sides. And that's all the properties of equalities are, is just that you're doing the same thing to both sides so that it stays balanced. If you only do it to one side, you're going to see what happened before, where it's not balanced. So you have to make sure you apply the properties of equality. What you do to one side, you always do to the other side. And you can see here, it's not balanced. Then don't forget to take a screenshot of it, put it into step number 2, and then you're going to highlight the solution. So again, we use the subtraction property of equality. So I'm going to highlight subtraction, and I'm just going to put it in yellow so you can see my answer choice is subtraction property of equality. Then the last step you're going to do is to simplify by combining the 0 pairs. So I'm going to highlight these 2 and put it on top of the other one. So I combine them. You can see now their value is 0. The right side, I have another set of 0 pairs, so I'm going to combine these, and you can see that's also 0. So now I'm going to take a screenshot of this and then paste it into step 3. And then the last step here you can see is to simplify and then check what the solution is. Your solution is always going to be once you isolate x, when x is by itself, what is on the other side? Nothing is here. So that means x is balancing with nothing, which means the only way that's possible is if x is also 0. So x has to be 0. So then I just put in x equal to 0 for my solution. And now we're going to go to number 2 and follow the same exact steps in terms of answering the questions and copying and pasting each part. So I'm going to click on here, and it's going to take me to the modeled equation, and I'm going to type in what I see here. So I can see I have an x and 2 negatives, and on the right side I have 3 negatives. So this represents the equation x minus 2 equals negative 3. So you can see here I typed in my equation x minus 2 is equal to negative 3, and I copy and pasted the model right there. Second question is property of equality being modeled. So now we're going to actually solve this. So when I look at this, I know that I have to solve for x, which means I got to get rid of these 2 negatives. The only way you're going to do that is by introducing 2 positives so that we have some 0 pairs that will cancel these out. And you can see here, now that I added 2 positives, it's not balanced anymore because, again, I only did it to one side. Anytime you're solving an equation, you got to use the properties of equality where what you do to one side, do the same thing to the other side. So you'll see here, I added 2 here. I also added 2 here. Now it's balanced out. So always do the same thing to both sides so it stays balanced. Otherwise, if you don't, as you can see here, it's not balanced. But by adding 2 to the right side, you can see it's balanced again. So again, that's what they mean by properties of equality. Now you can see I copy and pasted it here. And since my original equation had 2 negatives and now I added 2 positives on the left and right side, that means I'm using the addition property of equality because I'm adding 2 positives to both sides. So then I'm going to go over here and I'm going to choose the addition property and I'm going to highlight it yellow to show my answer choice. Now the last step is to simplify by combining your like terms. So I do that here. I'll do that on the right side as well. And you can see here now, my solution is being shown. Once x is by itself, what's on the other side? It's a negative 1. That lets me know that my answer or my solution is x equals negative 1. So I went back to the Google Doc, pasted my solution here. And again, x equals negative 1 balances with each other. So I'll put my answer x equals negative 1. So anytime you're looking for a solution in a model, always look for when x is by itself. And whatever's on the other side, that's always your solution. Because solution is the value that balances with x. All right, now we're moving on to number 3. So make sure where it says the equation is being modeled here is you click on that. And it's going to take you to the site. And you can see here, here's our equation. So I can see my equation here, I have two x's. So this would be 2x, and then 1, 2, 3, 4, 5, 6, 7, 8. So 2x equals 8. So make sure to take a screenshot, put it there, and then write down the equation that's being modeled. In this case, 2x equals 8. Now to solve this problem is a little bit different, but your goal when solving an equation is to figure out what's the value of 1x. We don't want the value of 2x's, we just want 1. So one way you can do that in terms of this one is by doing grouping. So we're going to split this up into two groups to figure out how many of these match up with one of the x's. So you can see here I created my two groups, right? You can see this x matches up with 4 1s. This x matches up with 4 1s. So you got to split your groups up into two even amounts so that way it matches up exactly. And this right here is how you model the division property of equality, because we took the right side and we divided it into two equal groups. And by creating that, we can see how much each of these matches up with. So I'm going to take a screenshot of this and paste that in the second step. You can see here, that was my original problem, right? It was a little bit messed up. I divided it into two groups, and now we can see each x matches up with 4. So again, this is called the division property of equality because we're dividing what we were given into two equal groups. Now that I know that each x matches up with 4 1s, I can delete one group like that, and I can see it's still balanced because we know each x is still worth 4 1s. So that lets me know that my solution is x equal to 4. So you can see here, I pasted my solution here, and I wrote down my answer, x equals 4. So again, by figuring out that each x matches up with 4 1s, I'm able to see that each x has to be equal to 4. So that's why by deleting this, it stays balanced because, again, these are both equivalent. So by removing the same amount from both sides, it still comes out to be balanced. Therefore, again, your x is equal to 4. All right, and now we're moving on to number 4, where we're going to model the multiplication property of equality. So again, click where it says here to access the problem being modeled. So we're going to take a screenshot of this, and we notice in this one, it says x over 2. So it doesn't say x, it says x over 2. So this is the equation, x divided by 2 is equal to 1, 2, 3, 4, 5. So x over 2 equals to 5 is the answer for this one, or the model for this one. Now to type in my fraction, I'm going to go over here where it says insert, and then I'm going to go down to where it says equation. And then you're going to go up here to the menu bar and go to this menu option here. 1, 2, the fourth one, go down to where it says a over b, and you'll see it's going to put an a over b here, so the fraction, and you're going to type in x divided by 2. And one thing to note, once you type in your top number, you can click on the bottom to put in your 2. And then I'm going to hit the right arrow key to go over 1. Now I'm going to hit equals. And then again, it was x over 2 equals, and there was 5 1s. So I'm going to put the number 5. So that's x over 2 equal to 5. Now we're going to figure out what's the property of equality used to solve for this one. So remember, we're always trying to figure out what's the value of 1x. Since this is a half of an x, you got to ask yourself, how many parts do we need to make one whole amount? So since we only have 1/2, I'm going to make another copy and make it into another half. So 2 halves make up one whole amount. So these together is going to make 1x because a half plus a half is equal to 1. But you'll notice when I added this half x, it's not balanced anymore. But remember, we said earlier 1/2 x is equal to 5. So that means that if I put another half x, I can balance it again by putting 5 1s on this as well. So basically, it's a copy of what we see here. We're going to copy both sides. So a copy of this, and now we're going to do another copy of that. So you can see here, basically, I just reorganized this so it's a little bit cleaner looking. So originally, we had this right here where 1/2 x is equal to 5 1s. And now what I ended up doing was I just copied the same thing on both sides. So now 2 halves make up one whole amount. And now we added the 5 1s as well on the right side, so it stays balanced. And that lets me know that one whole amount of x is equal to 10. And one way I can do this is you're going to highlight both of these on the left, and you're going to click where it says merge, and you'll see it's going to turn into 1x, because again, a half and a half makes one whole. 2 halves make a whole. So now we know x is equal to 10 altogether. So let me backtrack. I ended up forgetting to paste this in, so I went back and I showed my 2 halves, and I added the 5 on the right side. So right here again, this is showing the multiplication property of equality. So you're going to make sure you highlight multiplication in this case. And then after that, I merged these two together to make one whole amount. So I know that the value of 1x is equal to 10 altogether. And I'm just going to type that in here, x equals 10. So again, you can see x equal to 10. The original, again, 1/2 is 5, which means if I add another half on this side, I could get another 5 1s on this side, and it will stay balanced. So essentially, we're doubling it, right? We went from this, we doubled it, We went from this, right? I reorganized it because, again, this is 5. I doubled it to get 10. And now I know that when you combine these together, that's just one whole amount. And this together is 10. So x equal to 10 is our solution here.